let's say, we were interested, we already found that B equals 0, but we were interested maybe in this top chord member and this member down here on the bottom, FE. So let's think about how we would solve for those, okay? And again, we're not really constrained. We already used the y equation. We definitely want to be using the y equation for BC or FE because they don't have any vertical components to them, so they don't show up there. How would you, let's say we're interested in FE. What would be a nice way or a nice equation to use to solve for this bottom chord member?
Forces in X.
Well, sum of forces in the X. We already know that the X component of BE is 0, but we still have BC, so that there's still two X unknowns. The X equation is perfectly fine. It's just not going to get you anything right away. How about a moment equation? If I wanted to solve for this member, where might I sum moments about? B. B is a nice place to sum moments about if you're trying to find FE. Okay, because B cancels out the other unknown, BC. You already, BE was 0, but if BE had a magnitude, it would cancel out.
So it doesn't have to be coming like through it that way, as long as it's coming from that point, it cancels out?
Yeah, as long as it passes.
I wasn't sure when I was doing it. Because
Yeah.
I tried to sum from B, but I put BC in there.
No, because if it passes, if this was a ball, even if that BC was a mile away that way, it would be tied with a string, that ball would not rotate. Okay, so as long as the force passes through, then you ended up the distance of 0 in the moment equation, so it cancels or nulls out. So we saw moments about B. That'd be a good place. What do I have? Well, BE, BC, and that 10 kip force all pass through B, so there's no moment that they create about B. You do have this 10 kip force down here. How far away is it? Yeah, perpendicular distance of this distance now, which is 10 feet. Which way does it rotate? Clockwise. So for us, I'll call clockwise positive. Okay. What's the only other thing that you have? FE. So you got FE. How far away is FE from point B? 10 feet. That's going, in this case, counterclockwise. I'll call that negative. 0. 100 foot kips. I'll bring this on the other side. It's 10 feet times FE. I'll divide through by the 10 feet. Hey, what does FE equal? 10 kips. Now, that came out to be a positive 10, didn't it? That means that the direction of FE is correct. Remember, I started out assuming that it acted away. All right? So what does that mean to me? The same thing it meant when we were in method of joints. It means what? Tension. So FE is 10 kips tension. All right? All right, now how are we going to get BC? All right, now we can write the X equation if that's what you want it to write. That's fine. You could say some forces in the X now equals 0. I got FE. Here's the way my original equation would look like: plus FE plus BE cosine of that angle and plus BC Okay, there's no other x forces, so those would have to be equal to 0. So if you wrote that one at the very beginning, that's what you would have had. Well, we found out that FE was 10 kips. We found out that BE was 0. Okay? So now, here's what your equation becomes. Plus 10 plus 0 plus BC equals 0. What does BC have to be? Have to be a negative 10. What does the negative 10 kips mean?
Wrong direction.
Wrong direction, other direction. So that means it doesn't act out away from it, it actually acts back in. You can put it down as a minus 10, but for us, more importantly, that means compression. Okay? So, I mean, that's the way that you'd find it. Now, alternatively for BC, there is another equation you could have used besides the x equation down here. What would that be? There's a moment equation that you could have used. Not at F, actually out here at E. You know, there's a point E out here that you could have used that would have canceled this one and FE and would have left BC up there. Now some people say, hey, you can't use this point, it's not on your free body. I can use any point I want, as long as I know where that point is. Even though E is not on your free body out here, could you still use it? Sure, you could. So, but you could do it by the x equation too. So you really can use just about any equations that you want to use here as long as you solve the problem.